related to course 4 of AI project management from Purdue University. The course 4 talks about the human factors in AI, and in this video we'll discuss the factors that impact the development of AI. Okay. So based on the guidelines I have created these slides. So first is we need to talk about task analysis. So the task or the problem space that we are considering here is we are trying to identify the defective products on an assembly line. So there is a assembly line in a factory and which are producing some products, and we'll take the images of those products once they are constructed, and those images are analyzed by the monitoring system to identify whether they are defective or not. Okay, and the primary user of this is assembly line manager, and the assessment is like based on the task analysis we want to notify that the assembly line we want to notify about the defects to assembly line manager ASAP, and based on his review assembly line manager can take a call to stop work on that assembly line. So first is the trigger is when the defect of the product is identified, and action is to notify assembly line manager using the product monitoring app. Decision is to stop impacted assembly line. It is decided by the assembly line manager, and again action is to review the impacted assembly line for possible issues. It has to be done by the assembly line manager, and then the objective here is to identify defective products on assembly line early and notify assembly line manager so as to reduce the overall DPPM of the system. And the second consideration is for user experience design. So the product monitoring system that we are talking about, it will start when assembly line is started. As soon as an assembly line is started, the system will also start along with that, and there will be multiple methods to notify line manager, like they'll have a mobile app interface, there will be a system app interface, and there can be an alarm in the assembly line manager's cabin. If line manager doesn't respond in a stipulated line, then time, the notification will be escalated further to the upper management. Okay, then we have different design considerations like user input and any feedback loop. So user can accept or reject the reported defect. Transparency, we handle it by making sure that user has full control on whether to accept or reject the reported defect. User will have access to product images based on which the model is making his decision. And then communicating uncertainty, so user should be clearly communicated whether product is defective or not, 0 or 1, so that the line manager can decide whether to stop or to continue the assembly line based on his review. A probability of like 80% or 90% or 70% is not effective in this case. So the user will be provided with probability estimate on need basis to increase the confidence in model. Privacy considerations, so the images that we are collecting here, they are our customer IP designs, so it should be ensured that the images stay within the customer network and are not uploaded on outside servers. The different laws that may be applicable are Trademark Act, Copyright Act, Design Act and Patent Act, and we should be adhere to these acts when we are handling the customer data. Ethical considerations, so there are potential sources of bias in the imbalance in images of defective and non-defective parts. This is one of the potential source of bias, so we have to handle it by selecting the appropriate metric to evaluate the system. Other considerations like fairness is not applicable in our use case. Accountability is applicable, and the responsibility lies with the solution provider. He is fully responsible for the model output, and in case of any failure he has to analyze the failure to identify the root cause. It may be due to change in material on the assembly line, or maybe due to light settings, or maybe a model's bug which need to be fixed. Then the system should adhere to applicable company and national laws that we discussed in previous slide. And as a fallback mechanism, user has full control of rejecting the model output. System doesn't have any impact on normal functioning of the assembly line. So even if system has raised an alarm that product is faulty, the assembly line should continue to function until it is stopped by the line manager. User can run the assembly line without monitoring system. So if assembly line manager decides that the model is not effective, he can stop it and can run the system without it. Then the next point is transparency. The user has access to images which are used by the model, and user has full control of accepting or rejecting the model output. So these are all considerations for human factors. Thank you.